All right, guys, for this problem it says find the relative extrema of the function f of x is equal to 3x to the fifth minus 5x cubed plus 2. Well, relative extrema, one way that you can do this is find the first derivative, find the critical numbers, and then do a sign chart, and then, wherever the derivative changes sign, then you're either going to have a max or a min. So we could try that. Let's try that way. So the first derivative of this function would be 15x to the fourth minus 15 x squared, and then that is not undefined anywhere, so I'm just going to set this equal to 0. So 15x to the fourth minus 15x squared, set this equal to 0, pull out my GCF of 15x squared, so that'll leave x squared minus 1, and then this is a dot, so I can factor this into 15x squared, x plus 1, x minus 1, so that gives me my critical numbers of 0, -1, and 1. So there are my critical numbers. So I'm going to make my number line, and I'm going to put -1, 0, and 1. And then what I'm going to need to do is I'm going to need to plug in some test values. So I want to test -2, test -1/2, test 1/2, and test 2. And I want to see what the values of the derivative are on these intervals. So here's my derivative. So I'm going to plug in -2. Well, a negative squared is going to be a positive, so this is a positive. Don't worry about that. -2 plus 1 is a negative. -2 minus 1 is a negative. Negative times negative is a positive. So this is going to be positive here. If I plug in -1/2, -1/2 plus 1 is a positive, but -1/2 minus 1 is a negative, so a negative times a positive is a negative. Plug in 1/2. 1/2 minus 1 is a negative. 1/2 plus 1 is a positive. Negative times positive is a negative. And then plug in 2. 2 plus 1 is a positive. 2 minus 1 is a positive, so that would be positive. Now remember, you have a relative extrema if the derivative changes signs, and the derivative changes signs here, and it changes signs here. Now notice it goes from a positive to a negative, so that means that this is a relative max, and then this is a negative to a positive, so that's a relative min. So I have a relative min at 1 and a relative max at -1. Now, this isn't the only way that you could have solved this problem. You could have used the second derivative test. You already found the derivative, the first derivative, and you found those critical numbers, so that means that's where the derivative is 0. What you could have done is taken the second derivative of the function, so then that would be 60x cubed minus 30x, and then you could have evaluated each one of these numbers. So you could have evaluated 0, and you could have evaluated -1, and you could have evaluated +1, and gotten what those values are. So if you plug in 0 into this function, you just get 0, which means that it fails the second derivative test. So in other words, we can't use that answer. And if you notice in the first way we did it, you didn't have an answer there. But if you plug in -1, you're going to get -60 plus 30, and that's -30. And if you remember, whenever the second derivative is negative, that means it's concave down, and so that means it's going to be a max at -1. And let me double check. At -1, it was a max. That's right. Now, if we plug in +1 into here, we're going to get 60 minus 30, so that's a positive 30. The second derivative, if it's positive, tells me it's concave up. Concave up has a minimum value, so then there has to be a min here at 1. So again, guys, there's two different ways to do this. Whichever way you find more better is fine with me. You can either find the first derivative, find those critical numbers, and then do a sign chart, or you still have to find the first derivative, you still have to find the critical numbers, and then after you do that, find the second derivative and then evaluate those numbers, and then you can tell if the second derivative test fails, if there's a max, or if there's a min.